The question, only one compound, and the question will be talking about the ratios of the masses of elements present in a compound, right? Like water, we discussed. Okay, so water, what is the mass ratio of hydrogen and oxygen in water?
18 gram.
The mass ratio of hydrogen and oxygen.
1:8.
H2 and O2. So 2 grams hydrogen and how many grams? 16 grams. Okay, out of 18, 2 grams is hydrogen, and so ratio is 1:8. That ratio is fixed. Okay, that's what we discussed. Is it clear or not?
Yes.
Yeah.
That we discussed. Then what was the next law which we discussed?
Law of multiple proportion.
Yeah, multiple proportion. So what was that law? Multiple proportion.
It talks about several compounds formed by two elements.
Yeah, it talks about the several compounds, right? Okay. So, for example, how will you prove the law of multiple proportion in water and H2O? So you need to take the mass of any one element same in both the compounds.
Yeah, 1:2.
Yeah, so let's take the mass of hydrogen same. Yeah, 1:2. Mass of hydrogen is, because there are two hydrogens in this, there are two hydrogens in this.
Hydrogen
So
will be the base.
2 gram, yes, exactly. So when two elements combine to form two or more type of different compound, the ratio of masses of oxygen, in this case it is oxygen, that combines with the fixed mass of hydrogen. So that is the base, right? So I took the fixed mass of hydrogen, that is fixed, got it. So what is the mass of oxygen? Mass of oxygen is 16 grams because there is just one oxygen in water. And this is 32 grams. Even without the masses, you can, I told you the trick, just look at the ratio of the number of atoms. Okay. There is one hydrogen and two hydrogen. There are two hydrogens, so 1:2. So mass ratio of oxygen is how much? It is 1:2. So that's what law of multiple proportion is. So you take the mass of any one element fixed, the ratio of masses of the other element present in both the compound will be in simple whole numbers. Is it clear or not?
Yeah.
Yes.
So that's what we discussed. We discussed in carbon monoxide and carbon dioxide. So carbon is one same. The mass of oxygen that combined with same carbon in both the compound is in the ratio of 1:2. SO2 and SO3. The ratio of masses of oxygen,
2:3.
yeah, that combined with the fixed mass of sulfur is 2:3. Okay. So this is one law. There is Avogadro's law. What it is about? Avogadro's law.
The amount of molecules or atoms present in 1 mole is 6.022 into 10 raised to 23.
Yeah, Avogadro's law for gases. Yeah, that is Avogadro's number. For gases, okay, Yeah, it is related to the number. So different gases taken equal volumes of different gases. Let's say I take 22.7 liters, 22.7 liters of oxygen or helium, 22.7 liters of neon. Okay. So different gases, equal volumes. Equal volumes of different gases when taken at
0 Celsius.
same temperature and pressure. Are you getting my point? So the temperature and pressure is same. The temperature is T and pressure is P. This is also T and P, right? Aisha and Abdul, am I audible?
Yes.
Okay. So Aisha, what is going on in your school? Which topic?
Sir, actually today only I got admission in the school. So I don't
Okay. 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 No problem. So the first chapter is some basic concepts of chemistry may be going. Okay. And then I will give you some idea of the thermochemical reactions, and that will be useful in your all the chapters. Okay.
Okay.
So we discussed the laws. Okay. So laws. So just I was revising the laws with the Maha Nabila. So we discussed different laws in the last class. There is Avogadro law for gases. Avogadro number is related to the number of particles in one mole. Avogadro number that we know is 6.022 into 10 to the power 23. Okay. So Avogadro law for gases is something related to the number of particles only. So when different gases, equal volume of different gases is taken at same temperature and pressure, they contain equal number of their particles. Equal number of their particles, they could be atoms or molecules. That depend upon the type of gas. So helium, so the number of particles of helium and the number of particles of neon and the number of particles of argon, though they are different gases, they will be same. Is it clear or not?
Yes, sir.
Okay. So this is Avogadro's law. So gases, uh, irrespective of their type, if their temperature pressure is same and volume is same, their particles, number of particles will also be same. Okay. Suppose if I take, so can you tell me if you try to recall, this is for all of you. Suppose if you try to recall, if the temperature I have taken is 273 Kelvin, how much is 273 Kelvin? And pressure I take as 1 bar. Okay. Temperature 273 Kelvin is how much?
1 Celsius.
Temperature, actually there are different ways to measure. Yeah, 273 Kelvin.
Degree Celsius.
How much?
1 degree Celsius.
0 degrees Celsius.
Mm.
Okay, so suppose if I have, so temperature in degrees Celsius, temperature in Kelvin will be equal to temperature in degrees Celsius plus 273.15. Just note it down. Got it? This is the
Yeah.
temperature in Kelvin, or you can write it like this. This is the temperature in degrees Celsius. Okay, so you can get it this way. Okay, so if you take 0 degrees Celsius, normally we neglect this 0.15. So temperature in Kelvin going to be 0 plus 273, that is 273 Kelvin. Kelvin scale will be used in thermodynamics. Why we have taken the Kelvin scale? First of all, suppose you have 0 degrees Celsius. Okay, is it the lowest temperature?
No.
No, because suppose if we go to cold countries, there in summer, in winters, we see the season down the North Pole also. The temperature can drop below 0 degree. So this 0 is not the absolute 0. Clear? It is not the lowest value. So 0 Kelvin scale is the absolute thermodynamic scale. Have you understood what it means?
Yeah.
It is the absolute scale. It means suppose if I take 0 Kelvin, means this is the lowest temperature. There is no temperature below this. It is the lowest temperature, 0 Kelvin. Is the lowest temperature of the universe. This is not the lowest temperature because I can get down to -1, -2, -3. Okay. In our home also, the freezers have that much lower temperature. Okay. So degree Celsius is not the lowest value of the temperature. So that is not the absolute scale. Kelvin is the absolute scale. 0 Kelvin means 0. There is nothing below 0 Kelvin. Aisha, Abdul, Maha, Nabila, is it clear? So
Yeah.
absolute thermodynamic scale of temperature. Got it? Is the Kelvin scale. 0 Kelvin is the lowest temperature of the universe. It is the temperature at which all type of motion cease to exist. It is the temperature at which all types of motion stop. Normally, in your class 10th, you might have studied that the solid, the particles are fixed, okay, and they do not move from place to place, they just vibrate.
Yeah.
That you must have studied. In the liquid, the particles are moving within the liquid. In the gas, the particles are moving throughout the container. They are moving up and down and everywhere. And if we cool a gas, it becomes liquid. If we cool it further, it becomes solid. The particles of the solid can vibrate. They do not move, but they vibrate. They exhibit vibrational motion. And if I cool it to 0 Kelvin, even the vibration of the particles stop. They don't even vibrate, right? They actually stop all type of motion. So what is 0 Kelvin? Is that clear?
Yeah. Yes.
It is the lowest temperature of the universe. It is the temperature at which Abdul, Aisha, all the motions of the particles stop. Okay. Clear. So in thermodynamics chapter, we are going to use the Kelvin scale only. In chemistry also, we are going to use the temperature in Kelvin. Got it? So this 0 Kelvin in degrees Celsius, how much it will be? Can you tell me? How much will it be in degrees Celsius?
-273.
So Kelvin is 0 Kelvin, right? I will put the 0 in place of temperature, which is there in the Kelvin. 0 Kelvin equal to temperature in degrees Celsius, right? And 273.15. Okay, temperature in degrees Celsius is going to be minus 273.15. That is equal to 0 Kelvin. Got it? Clear?
Yes. Yeah.
So if we go to some other galaxy or somewhere there where any isolated place of universe, you will see that the lowest temperature which they have recorded with the telescope, and now we have the James Webb telescope. You might have studied, right? So that also with that, and there are various instruments by which you can record the temperature. That is the lowest temperature. So Kelvin scale is the absolute thermodynamic scale. Is that clear? So in thermo also, we are going to measure the temperature in Kelvin. Temperature is 273 Kelvin and the pressure is 1 bar. This is the standard condition. This is known as STP. Okay, and this is that also we have discussed in the mole concept, that at this standard temperature and pressure, the volume occupied by 1 mole of a gas is 22.7 liter. One mole means how many particles? Aisha and Abdul, tell me. 1 mole. How many particles of argon? How many particles of neon? 1 mole means 6.022 into 10 to the power 23 particles. It is just like a dozen. We have studied that. Dozen mean 12 particles. So mole means 6.022 into 10 to the power 23 particles. So all gases, if they have equal volume at same temperature and pressure, they will have equal number of particles.
But
And if
sir, usually for 1 mole of gas, we use 22.7 liters like, for gases.
yeah, volume is, yeah, exactly. So at STP, but that is at STP only. Standard temperature and pressure. Standard temperature is 273 Kelvin and pressure is 1 bar. Got it? If you increase the pressure, suppose if you increase the pressure to 2 bar, what will happen? The pressure will be doubled. If you apply more pressure, what will happen? The volume will get hot. Just like balloon. Balloon, if you try to compress, what happens? Its volume contract, the pressure increases.
So if the standard pressure is like 0 bar, then only you have to use 22.7, or else you have to use the Avogadro's number.
Standard pressure is set, that is 1 bar, and temperature is 0 degrees Celsius. 0 degree, 0 Kelvin.
the bar.
Why we use the bar? Because bar is actually the standard way to measure the pressure. Is it clear? So
The
bar,
measure?
yeah, pressure, exactly. Bar is the unit of pressure. So standard temperature is 273 Kelvin or 0 degrees Celsius, and pressure is 1 bar. So if all different gases, when taken at 1 bar and 0 degrees Celsius, they are going to have the same volumes, 22.7 liters, and they are going to have the same number of particles. That is 1 mole of particles. 1 mole of particles, constituent particles. If they are atom, they will be atom. If they are molecule, they will be molecules. Okay, and these will be 6.022 into 10 to the power 23. Is that clear?
Yes.
Yes.
Abdul Aisha, is it clear?
Yes.
Okay. Suppose I will give you another example. So this is Avogadro's law for gases. If you have different gases, but if you keep their temperature, pressure, volume as same, okay, they will have equal number of moles. That is Avogadro's. Irrespective of the gas, if the temperature is same, pressure is same, volume is same, their particles are also going to be same. Got it? Avogadro's law. And how many particles will be there at STP? And 22.7 liter. At 22 at STP, 22.7 liter will have 1 mole of particles. Of gas. How much? It will be
6.022 into
22.7, and that is number of 6.022 into 10 to the power 23 particles. Got it? That is also known by the name of 1 mole. Okay.
So, sir, in the question, the bar is not given as 0 Celsius, given more as like 2 Celsius. So we have to multiply 2 into 22.7 liters.
Where?
Like in a question, if it's given like the standard bar is not like at 0 degrees, but like a more. So we have to multiply it into
No,
22.7.
standard, they will write STP. And now this STP is fixed. Okay. IUPAC has fixed it. So all of us, whether you are in USA or UAE or KSA, right? You have to take STP same. Okay, for all. Because it is decided by IUPAC.
So in the question, it will always be 0 degree. 0
Yeah.
degrees Celsius.
If they have mentioned STP condition, that will be 0 degree, 273 Kelvin, Got it? Both are same.
Okay.
And the pressure will be 1 bar. Okay. And that 1 bar pressure, if 1 mole, the volume will be 22.7. Okay, let's me, because this gases part is going to come in thermodynamics also, this temperature is very important. Suppose if I have taken 11.35 liters of neon gas. Where do we use neon gas? Neon gas is used in glow signs. Okay, a lot of advertising you might have seen, displays. Okay, there they use that fancy lights. Okay, which emits colored lights. Okay, in marketing and
LED
all.
lights?
Yeah, LED lights, and the there are lights also with filled with neon gases. They actually uh, exhibit orange color, right? So that is the neon gas. So suppose 11.35 liters of neon gas at ST. So how many moles of neon gas we have taken?
We have to divide 11.35 by 22.7.
Abdul, Aisha and Abdul, are you getting my point?
Yes.
So we can apply the unitary method. 22, when the volume is 22.7 liter, it was 1 mole. Got it? When it is 1 liter, this is many to 1. Many to 1, what you do? Divide. This is 1 by 22.7. And how many liter I have taken? In the question, I have taken 11.35 liters. 1 to many, multiply. Okay. So multiply with this. Got it?
Yeah.
So this 11.25, 835 is just half of 22.7. So it is right. This is mole, not liter. So this is half mole. Got it? Is that clear or no?
Yes.
Yeah.
Yes, sir.
So it is just like Aisha, Abdul, Maha, and Nabila, that suppose if you take 22.7, it was 1 mole. When you half the volume, the moles also got halved, or the number of particles also got halved. So how many particles of neon will be there?
Yes.
Number of particles will be half of whatever is there in 1 mole. 1 mole contains 6.022 into 10 to the power 23 particles. So half mole will have just half of the 3.011 into 10 to the power 23 particles. Got it?
Yeah.
That clear? I hope this is clear to everyone. Nabila, is it clear?
So can we do another question?
Pardon?
Another question.
Yes. So find the number of moles of CO2 in, let's say, 227 liters at SQP. So how many moles of CO2 will be there?
So 1/10.
You can remember either this formula,
10 moles.
number of mole equal to given volume divided by molar volume. You can write it in words first. Number of moles at STB, given volume in liters. This to be applied for gases only. And this is in line with the Avogadro's law of gases, which says that if you take different gases and if you keep their temperature, pressure, volume same, their particles are going to be same. And 1 mole of particle of the gases occupied 22.7 liter at STP. Okay. Either you can apply the unitary method. This volume is how much of 22.7? How many times of 22.7? 10 times, right? 10
Yes.
times of 22.7, right? Because the decimal has been shifted in the right hand direction. So it is 10 times. So the number of particles will also be 10 times. Okay, if the volume is same, the particles are same. If you increase the volume by 10 times, the number of particles will also go by 10 times because you have kept the temperature, pressure same. So 10 times of 22.7 is 227. So or you can, if you don't want to think in that way, you can remember this formula for gases only, but do write it. Number of moles of gases will be given volume in liters. Given volume is how much? 227 divided by volume of 1 mole. So it is going to be 10 times. So 10 moles I have taken. Clear?
Yeah.
So is the
Yes, sir.
Avogadro's law of gases clear to you?
Yeah.
Different gases.
Yes, sir.
If the temperature, pressure, volume are same, the particles are same. But if the volume is increased 10 times, the number of particles will also go 10 times. Okay. If the volume is half, the number of particles or the number of moles will also get half, right? You can call them as 1 mole, that whole bunch of particles. Okay. In short, you can call them 1 mole. 1 mole is 6.022 into 10 to the power 23 particles. If you half the volume, you will have half mole. Okay. If you take 10 times volume, you will have 10 moles. Got it. Right? So that is Avogadro's law. Next is similar law is there. Okay. That is for the reaction for gases. Okay. You can apply it for the gases. Okay. It is known as Gay-Lussac's law of combining volumes. This is also similar in line with the gases and all. So Gay-Lussac's law of combining volume, it is actually related to gases, as the name indicates. Okay, and basically it is also related to the Avogadro's law, the number of particles. Okay, so suppose when the gases undergo chemical reaction, so this is a chemical reaction which involves gases only. Nitrogen gas is there, hydrogen gas is there, and when they react they form NH3, that is ammonia. Got it?
Yes, sir.
So suppose when you are doing this reaction, you are taking all the gases in a container, because you are dealing with the gases, so you have to take all of them in the same container. So the temperature and pressure will be okay in as per the container, right? Yeah. And this chemical equation
Yeah.
is telling that 1 mole of nitrogen combines with, this is 3 moles of hydrogen, giving you 2 moles of NH3. Okay, is it clear?
Yeah.
Yes.
And
Yes,
just
sir.
now we have seen, Aisha, that the moles are actually, suppose if you keep the temperature, pressure same, and volumes will also same. If you have kept the volume same, their moles will be same. And if you take volume 10 times, the moles will also become 10 times. Okay, that's what we have seen just now. So when the gases react, the reaction is as per the equation, balanced chemical equation. You have the coefficients which represent the mole of each gases. So because they are gases, they are taken in volumes. Okay, so volume is directly proportional to mole. So when the gases react with each other, so what is the law? That is very simple. That moles are proportional to the volume. Just now we have seen. So you can write the same thing. You can relate in the same way by which you have related the moles. By looking at their coefficients, you can also relate their volumes. Suppose if I take 1 liter of nitrogen, how many liters of hydrogen do I need under same temperature pressure? How many
3
liters
liters.
of hydrogen? Yes, 3 liters. So the particles are 3 times, got it? If the particles are 3 times, 3 moles, the volume will also be 3 times of the volume of nitrogen. So when 1 liter of nitrogen combines with 3 liters of hydrogen, you get 2 liters of ammonia. This is called Gay-Lussac's law of combining volume. So when the gases react, the volumes are in the ratio of their moles, represented by their balanced chemical equations. Got it?
Yeah.
So suppose if I take 10 liters of nitrogen, how many liters of hydrogen will I need?
30.
Yeah, 30 liters. Got it, of hydrogen. And when they react completely, how many liters of ammonia?
20 liters.
20 liters. Yeah. Is it clear? So this is a very basic thing. So you already answered very well. So this is called Gay-Lussac's law of combining volume. Now I will write the law. Okay, the official language of law. So it is when the gases react with each other. So how you take volumes of gases? They do so okay, suppose if I bring a balloon made up of filled with nitrogen. So in order to react this one balloon of nitrogen, I require 3 balloons at the same temperature and pressure for filled with hydrogen of the same size. Got it? So when the gases react, they react in terms of volumes because the gases are measured in volume.
Volume.
Got it? So when the gases react with each other, they do so in volumes.
So 1 volume is also equal to 1 mole, right?
No, not one mole. That is one volume, not one volume. But that 22.7 liters is equal to.
Mm.
Okay. At ST. Okay.
Okay.
This you can remember. So I have not calculated this, the actual, but I know that this is one. If 1 mole, that will be 3 mole. So whatever the volume will be
So
there.
we are just imagining that they are 1 liter, 3 liter, and all that.
Yeah, we have just imagined.
Okay.
If I have
Okay.
imagined, so whatever my imagination volume I have chosen, one without calculating how many moles I took, one thing is sure that the moles of hydrogens will be thrice because the equation is telling me, and the volume will also be thrice. So when the gases react with each other, they do so in volumes. Is the meaning of this statement clear?
Yeah.
Yes.
Which are proportional to their number of moles or particles. Got it?
Yes.
But this is valid at same temperature and pressure. This will not be valid if you take nitrogen at 0 degree and hydrogen at 100 degrees. Because 100 degrees it will have very high volume. It will expand. So then I cannot relate the volumes of the gases. Okay. But if because they are part of a chemical reaction, they are taken in the same container. So I assume that the temperature and pressure are same for all the gases at same temperature and pressures. Is it clear? So the so whatever the mole ratios are there, that will be the ratio combining ratios of their volumes for gases. Okay, be careful. So when they react with each other, they do so in volumes which are directly proportional to their number of moles or particles. Okay, or we can say the gases participating in a chemical reaction combine or react with each other in terms of their volumes. which are in the ratio of their number of moles represented by their balanced chemical equation. Is it clear or not? So
Yes, sir.
this is the same thing said in a different way. So when gases combine or react with each other, okay, they react with each other in terms of their volume. One volume or two volume, okay. That volume can be liters or it can be ml. Okay, I'm using a general term volume. Okay, the unit you can decide as per the given in the question. Okay, so they do so in terms of their volumes, and those volumes are not arbitrarily chosen. They are in the ratio, the in the number of ratio of their number of moles represented by their balanced chemical equation. Is it clear? For example, H2 and O2 gives H2, right? So if I take 4 ml of hydrogen gas to react completely, how many ml of oxygen gas will be required?
2 ml.
Because this is twice the volume, so this should be half of the volume of the hydrogen. Okay, so this is 2 ml. And if the water vapors are found, how many ml of water vapors will be formed? 4 ml. Okay, if I take it as vapors. Okay, but there is a condition, there is a criteria that need to be fulfilled, that all the three should be measured at same temperature and pressure. Is it clear?
Yes.
Okay, so if they are at different temperature and pressure, then I can't relate their volumes, because gases volume can vary very largely depending on their temperatures. If you heat them, they expand. So whatever the temperature which you are taking, okay, that should be same for all the three, for all the reactant gases, reactant, and products. Is it clear or not? Okay, so
It's clear.
uh, in the next class, Nabila, you are going to send the list of the topics, okay, to the management. You can talk, right? Whatever the topics which are covered in the thermodynamics, just you can message, okay, and you can verify from your classmates in the school, okay. So we can cover those topics quickly. And what about I think Abdul and Aisha, you also, what is going on in the school? So
Okay.
just message to the man, right? So that we can decide accordingly, right? So I hope this is clear. Let me in today's class. Okay. So bye bye everyone. Good night. Take care.
So
Thank
don't forget
you
to
so
change
much.
that assignment, the last assignment.
Yeah, assignment need to be rectified, because that is